Imagine a tiny plastic fitting surviving decades beneath busy streets without anyone ever noticing its incredible journey. Most people never think about these small connectors, yet entire cities depend on them every single day without failure. But here's what nobody tells you. Every fitting begins as tiny plastic pellets no larger than grains of rice. Within hours, those tiny pellets transform into precision-engineered parts that safely carry water across thousands of kilometers. Think about this. One hidden fitting can protect clean drinking water for more than 50 years underground. That incredible lifespan depends on chemistry, precision engineering, and factories running around the clock without stopping. You are about to enter a factory where heat, pressure, and perfect timing create components trusted across the world. The air smells warm with heated polymers, while powerful machines create perfectly shaped fittings every few seconds. What happens next surprised even experienced engineers when modern automation completely transformed the traditional manufacturing process. And this is where our journey truly begins, with the remarkable raw materials hiding inside every single plastic fitting. Everything starts with crude oil and natural gas, extracted thousands of meters below Earth's surface before becoming high-performance plastics. Major supplies come from the United States, Saudi Arabia, Qatar, Canada, and Norway, feeding chemical plants across the globe. Inside giant refineries, hydrocarbons separate into valuable chemicals through intense heat reaching nearly 850 degrees Celsius, or 1,562 degrees Fahrenheit. That extreme heat breaks large molecules apart, creating ethylene and propylene, the building blocks for modern engineering plastics. Most pipe fittings use PVC or polypropylene because they resist corrosion, chemicals, moisture, and decades of constant pressure. Manufacturers demand resin purity above 99.8% because even tiny contaminants can weaken finished fittings beyond acceptable engineering limits. Every shipment travels hundreds or even thousands of kilometers inside sealed rail cars, trucks, and specialized shipping containers. 1 metric ton of premium resin may cost between $1,000 and $2,000 before processing even begins. But resin alone cannot survive decades underground. So engineers carefully blend stabilizers, pigments, antioxidants, and ultraviolet protection additives. Most people never realize these invisible ingredients determine whether a fitting lasts 5 years or 50, and the next step reveals how. Now, the real transformation begins as thousands of resin pellets rush into giant drying hoppers before the molding process starts. Hot air circulates at about 80 degrees Celsius, or 176 degrees Fahrenheit, removing moisture during nearly 2 hours of drying. Even tiny drops of moisture could create bubbles, weak spots, or cracks inside the finished fitting after molding. Next, vacuum conveyors carry the perfectly dried resin directly into the injection molding machine without exposing it to humidity. Inside the heated barrel, a rotating screw spins around 120 revolutions every minute, pushing resin forward. Electric heaters raise temperatures between 190 and 230 degrees Celsius, or 374 to 446 degrees Fahrenheit, depending on the material. The pellets soften, melt, and blend into thick liquid plastic that shines like glowing honey under powerful industrial lights. Hydraulic pressure suddenly reaches nearly 1,500 bar, forcing molten plastic into hardened steel molds within seconds. Every mold contains mirror-polished cavities that shape elbows, T's, couplings, reducers, and threaded adapters with incredible precision. But here's the surprising part. The plastic looks finished already, yet its toughest challenge has only just begun. Inside the closed mold, chilled water channels remove heat rapidly while the plastic hardens into its final engineered shape. Cooling usually lasts between 20 and 60 seconds, depending on the fitting's thickness, diameter, and engineering design. When sensors detect the perfect temperature, the steel mold opens with a sharp metallic sound echoing across the factory. Powerful ejector pins gently push each fitting free, without leaving marks that could weaken future pipe connections. A robotic arm grabs every hot fitting within seconds, preventing scratches while keeping production moving around the clock. Some production lines manufacture more than 1,000 precision fittings every single hour, without slowing down. Workers inspect machine screens constantly, adjusting pressure, temperature, and injection speed before tiny problems become expensive defects. Freshly molded fittings still carry tiny runners and gates that specialized trimming machines remove with remarkable speed and precision. Some threaded fittings move into CNC machining stations where rotating tools cut perfectly accurate internal and external threads. Everything looks complete, yet one hidden inspection will decide whether these fittings reach customers or become recycled material. Now, every fitting faces its toughest tests, because one invisible flaw could cause a costly leak years later. AI vision systems inspect every surface in milliseconds, spotting scratches, flash, cracks, and tiny dimensional errors invisible to human eyes. Laser scanners measure every diameter within plus or minus 0.1 millimeters, ensuring perfectly sealed pipe connections. If measurements drift beyond tolerance, robotic arms instantly remove the defective fitting without slowing production line. Modern factories reject fewer than 1% production, yet every rejected piece gets recycled instead of discarded. Pressure testing pushes water beyond normal operating conditions, proving every design can survive years of demanding service. Some fittings endure burst tests exceeding 40 bar before engineers approve the design for commercial production. Experienced technicians still outperform machines by feeling tiny imperfections that advanced sensors occasionally fail to detect. After passing every inspection, each fitting receives traceability markings, linking it forever to its exact production batch. But the journey is far from over, because these ordinary-looking fittings quietly support modern civilization across the entire planet. Plastic pipe fittings support drinking water, irrigation, construction, gas distribution, and industrial systems in nearly every country on Earth. Today, manufacturers produce billions of plastic pipe fittings every year to meet the growing demand for reliable water and infrastructure systems. The global plastic pipe and fittings market is worth tens of billions of US dollars and continues to grow as cities expand. China leads global production, followed by India, the United States, Germany, and Turkey, with thousands of factories operating every day. Together, these manufacturing centers employ millions of engineers, machine operators, quality inspectors, logistics specialists, and maintenance technicians. More than 50 years ago, metal fittings dominated plumbing systems, but lightweight plastics gradually transformed the industry through lower costs and greater corrosion resistance. Modern plastic fittings can resist chemicals, moisture, underground pressure, and harsh weather for decades with minimal maintenance. Did you know that some underground plastic pipe systems are designed to last more than 50 years before needing replacement? Did you know that automated production lines can manufacture thousands of precision fittings every hour while maintaining extremely tight quality standards? Did you know that many rejected plastic fittings never become waste because manufacturers grind them into recyclable material for future production whenever quality requirements allow? From underground water networks to massive industrial plants, these small components quietly keep modern life moving every single day. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.